All right, so what we're going to do in this video is we're going to continue our discussion about factoring polynomials. So grab your spiral notebook and you can just kind of pick up where you left off. We're going to talk about the last two types of factoring. So before we get into this factoring method, I'm going to just throw in, we'll just call it a little bit of review, right? Let's just review a little bit of multiplication. Now what I'm really doing is I'm going to try to establish here a type of problem that maybe we can notice some patterns. All right, so I'm gonna kind of put this as my first review, and then maybe down here, let's do 3x minus 1 and 9x squared plus 3x plus 1, okay? So you can multiply this out with me, or if you wanna hit the pause key, you can go ahead and work through it on your own, and then fast forward and see if you got this one right. All right, let's go ahead and fast forward this. I'm sorry, let's go ahead and work through these, my apologies. And so we're going to basically take the x and distribute. We're going to get x cubed, and x times negative 2x is negative x squared. And then we're going to take 4 times x. All right. And then basically we take the 2 and we distribute it, and we kind of work through in the same way. And then 2 times 4 finally is 8. Now what's interesting with these problems is what happens when we combine like terms. Okay. I'm going to go ahead and get rid of my lines here so I can go back to the original problem a little bit easier. So there's no other x cubes. I see that the negative 2x squared and the positive 2x squared equals 0, and positive 4x and negative 4x equals 0. And basically, the result is x cubed plus 8. Okay, so it's kind of interesting. We can look back and see if we notice any patterns with this. All right. Well, let's do one more and see if maybe the same thing happens. I'm going to distribute the 3x to the 9x squared and get 27x cubed. And 3x times 3x is going to be 9x squared, and 3x times 1 is plus 3x. Now we're going to distribute that negative one, right? Negative 9x squared, negative 1 times 3x, and finally negative 1 times 1 is negative 1. So let's go ahead and combine like terms and see what's going on. All right, so we get 27x to the third power, and 9x squared and negative 9x squared equals 0, and 3x and negative 3x equals 0, and finally, so the same thing happened again, where we multiplied this out, and we ended up with this binomial, where all of the stuff in the, we'll say the middle, kind of equaled 0 or canceled out. So what I want to look at is, there is definitely a pattern, and a few things that I notice when I look at this pattern, okay, a couple things that I notice, is I kind of notice here that if one of the signs is plus in the middle, that this middle sign is going to be a negative. So that's part of the reason that some of this stuff is canceling out. I notice here, again, that same pattern happens where the signs are the opposite. So we can remember that when we go to do this. The other thing I maybe notice is that if this is a 2, that this is the perfect square, 2 squared, which is 4. And if this is a 1, then this is 1 squared. So there's a lot of patterns to be seen with this. Basically, what I'm leading you to is this type of factoring is, oh, let me talk about this before we move on. The other thing is, what I notice about these numbers is that 8 and 27 and 1, these are special types of numbers, and these numbers are called perfect cubes, okay? So what I want to get into next is the next type of factoring, which basically what we're going to learn to do is we're going to learn to take x cubed plus 8, and I'm going to teach you how to break it down into the parentheses that multiplied. Okay, so that's really what we're going with this, is I want to teach you how to go backwards. And what this type of factoring is called, this is called the sum or the difference. And I think that's important to notice that this worked whether I gave you a plus in the middle or a minus in the middle, okay? It works either way, so it's the sum or difference of cubes. All right, so let's go ahead and bubble this in. This is our next big type of factoring. We're gonna look to use this type of factoring when you have two terms that are perfect cubes. So that's when I'm going to know. So one of the types of factorings is when we have perfect squares, but this type of factoring is what we're going to do when we have perfect cubes. So let's make a list here of our perfect cubes. We know that 1 to the third power is 1. Now 1 is interesting because it's also a perfect square. So there's other numbers that are usually more of the tell. 2 to the third is 2 times 2 times 2, it's going to be 8. 3 to the third is 27. 4 to the third is 64. So this is where we need to be careful, is 64 is a perfect square and it's a perfect cube. 5 cubed is 125. And so when we're looking at a problem that has x to the third power and has these numbers, 1, 8, 27, 64, that's what's going to tell me that it's this kind of factoring, which is the sum or difference of cubes. Okay. Now, I'm going to do this kind of first here. I'm going to first do an example. I believe this is example 7. Okay. I believe this is example 7 if we're keeping this going. And so what I want to do first is let's just factor something basic. Let's see, let's just factor something basic like x cubed minus 27. Okay? I'm going to run through how to do it, and then what I'm going to do is I'm going to show you the formula that you can use that we're just going to basically have to memorize. All right, so what we do when we factor is we understand that once we recognize that we have the difference of cubes, what we saw up here, okay, what we can see is that it always factors to be this binomial and this trinomial. So that's what I'm going to kind of set this up as. This is going to be, let's see here, sorry. This is going to be a binomial and this is going to be the trinomial. Now, in this binomial right here, these numbers end up just being the root of each of these cubes. So if it's x cubed and then the root is just x. If it's 27, the cubed root of 27 is 3. So it's basically like what term, when we raise it to the third power, gives us these. And the same sign comes down. And so that's what you notice in that first binomial, is that it's just the root of each term. Now, over here, we have a first term, a second term, and a third term. This first term is just going to be this first root squared, okay? It's just going to be that first root squared. This middle term is going to be the two roots multiplied together, and you get 3x. And then finally, this last term is going to be the last root squared. And you can look up at the problems we did, and that happened on both of these, okay? That this trinomial was the first root squared, you multiply them in the middle, and it was the last root squared. So that was happening before. Okay, now the signs are going to go like this. This first sign is going to be the same. This middle sign is always going to be the opposite. And so this means it's going to be a plus. And this last sign is going to be always positive. And so there's a nice little acronym that can help you remember how the signs go. And the acronym for the signs is the acronym SOAP, okay? Where the S stands for the same sign. The middle sign is always the opposite, and the A and the P stand for always positive. So what happens is students end up kind of associating this factoring type with the acronym SOAP. They'll kind of say, is this the SOAP factoring? Which is fine to say as long as you understand what it is that you are doing when we use this, SOAP factoring right here. All right, so what we need to get to is there is a formula. Okay, there's a formula that you can use. And whenever we have an a cubed plus a b cubed, okay, it could be variables, it could be numbers, it's always going to split to be a binomial and a trinomial. And this first binomial is going to be the two roots of these terms, okay? This is just going to be, these are going to be the roots. And then finally, the trinomial, we're going to take the first root. Remember, we take the first root and we square it, and you're going to get the first root squared. In the middle, you're going to take the two roots and you're going to multiply them. And then finally, the last term in this is going to be the last root squared, okay? And then what the signs are going to do is the signs are going to go same sign. This is going to be the opposite, and then the last one is going to be always positive, okay? So let's go ahead and write out the formula for if you have an a cubed minus a b cubed. Again, it's a binomial and a trinomial. And this first binomial is going to be the two roots with the same sign in between. And then you're going to square the first root, multiply the two roots in the middle, and square the last root. And the signs are going to go same sign, opposite sign, and this last one is always positive. Okay, so it's really not too bad of a factoring method. You know, it's kind of pros and cons, as it's not this like guess and check puzzle thing like the trinomials can be, but at the same time, it's a formula, but you have to memorize the formula. But hopefully through practice and repetition, you will find that it's really pretty easy to remember this formula. Okay, so let's go through. Example 8 is going to be 24x to the 5th plus 3x squared, okay? So when I first look at this, I don't see the x cubes, I don't see my perfect cubes. I'm gonna scroll up here, right? I don't see my perfect cubes of 1, 8, 27. But what I do notice is maybe we need to take out a GCF first, okay? And that's where I need to remind you that all of these factoring methods kind of go together. We need to always start by looking for a GCF. And so what I'm going to do first is I notice that both of the terms are divisible by 3 and that both of the terms have at least 2 x's. So now let's factor out a 3x squared and see what the result is. We're left with an 8x with 3 x's left over, and if we have a 3x squared and factor out a 3x squared, this is going to make a plus 1 in that spot. Now what we can see is I see the perfect cubes with the 8 and the 1, and so now we're going to do the sum of cubes, okay? And I'm going to use that first formula that we talked about. So the GCF is part of your answer. It stays out here, and this is going to factor into that binomial and that trinomial. And so the first parenthesis is going to be the two roots. Well, the cubed root of 8 is 2. The cubed root of x squared is x, and the cubed root of 1 is 1. All right? So now we square the first term. So when we do this, we square the first term. Now be careful, when you square the first one, you have to square the 2 and the x, okay? And then what we do is we take our two roots and we multiply them in the middle. And then what we do is we take the last root, oops, just trying to erase the green there. And then we take our last root and we square it and we get 1. And the signs go same sign, opposite, and this one's going to be always positive, okay? And this would be your answer. It would be 3x squared times 2x plus 1 times this trinomial 4x squared plus 2x plus 1. And that's where we're going to start combining a couple different factoring methods there, okay? All right, let's go over our last type of factoring, and this is going to be what's called factor by grouping. Okay, factor by grouping. And this is what we're going to look to use when we have 4 terms. All right, I'm not saying that it works for every polynomial that has 4 terms, but if it does have 4 terms, we're going to look for it. So where are we at here? Let's go ahead and pick up with example 9. Okay, this factoring is pretty easy. I don't usually feel like students have too much of a trouble. Let's make this 3x cubed. Let me just draw that again. 3x cubed plus 6x squared plus 4x plus 8. Okay? Once you get good at this, you can kind of tell by looking if it's going to factor by grouping, but I think initially going into it, we might just need to try it and then see. All right, now factoring by grouping, what it's going to, basically what I'm going to rewrite the original problem. Okay, I don't want to put my parentheses over the original. All right, so factor by grouping lives up to its name because what we're going to do is we're going to group the first 2, and then we're going to group the second 2 terms. And so we're going to group right here, okay? And then what we're going to do is we're going to factor a GCF out of each group. And so the GCF of this first group is going to be, let's see here, a GCF is going to be 3x squared, and the leftover part is just going to be an x plus 6 divided by 3 is going to make 2. And then I take a GCF out of this group, and the GCF is 4, and the result is x plus 2. Well, now this should look familiar with what we did in the very beginning of these factor polynomial notes. We talked about being able to factor out a GCF. Again, this is not factored. This is something, let me do this in a different color. This right here is something plus something. That's not factoring. Having a plus in the middle is not factored. What I can do is I can factor out a GCF again, and the GCF is x plus 2. And so if we factor out the greatest common factor of x plus 2, then the result of what's left over is going to be a 3x squared plus the 4 right here, okay? And this is kind of like the leftover. All right, and that's how factor by grouping works. So I think we should try one more problem, okay, just to make sure that you've got the hang of it. But I think factor by grouping flows pretty well. And again, it's not really this guess and check thing. It really just kind of, it either works or it doesn't work. All right, we're gonna start, and I'm gonna rewrite this problem, but this time, okay, with this minus, well, I'll just go ahead and rewrite the problem first. Okay, so when we group the terms, we obviously can group these, but then it kind of creates this, okay, what do we do with this negative? Do I put that negative in the parenthesis? Do I put it out of the parenthesis? And what I'm gonna have you do is I'm gonna have you turn this, I'm gonna have you make the x negative, so let's make this a plus sign, right? And let's just make the x negative, so then when we group it, the negative is with the x, okay? So that's the thing, is you want the negative to be inside the parenthesis, but then it's like when you kind of do it like that, then you're like, well, what's in between? Well, there'd be a plus sign in between the parentheses. So that's really kind of what I'm doing right there. Now I'm gonna take out my GCF. The GCF here is x squared, and the result is x minus 3. Now that when I look at this, I don't really see anything common between x and 3. Well, if there's nothing common, you can always factor out a 1. But in this case, because of that negative x, we're gonna factor out a negative 1. And the result is going to be a positive x, and 3 divided by negative 1 is going to be x minus 3. So you know you're doing factor by grouping correctly when you look at this and you see that you get the same thing in the parenthesis. When you see that you get the same thing in the parenthesis, then what that means is we need to go one more step, and we need to factor out the GCF, which is x minus 3, okay? And then the result is x squared minus 1 left over. All right, so now when I look at this, the biggest thing that we're gonna have to learn is making sure that we factor completely. Well, now I look at this, the x squared catches my attention. This right here is the difference of squares, right? We have a perfect square minus a perfect square. So I can leave this as x minus 3, but the difference of two squares can split into x and x. 1 is a perfect square, so we can split into 1 and 1, and the signs go plus minus. So that's what we're going to work on, is number 1, knowing how to use each factoring method, but then at a higher level, making sure that we can recognize when different factors need to be factored more. Okay? Well, that's it for now. Hope you got all of the examples in your notebook, and we'll go from there.